Well, welcome everybody to the second of our Dean's Lectures this year, and we're just thrilled to have everybody here. As you know, everybody knows earning the get to the point where you're appointed and promoted to full professor is a huge accomplishment. And it confirms not only the respect and high regard of the school, but also of colleagues across the nation and around the world. And so it's a momentous occasion. Now, Jeff was promoted a little while ago, but not too, we're a little bit behind in getting these, we get so many good promotions that we're a little bit behind in the schedule, but. The Dean's Lecture Series, as you know, was designed to introduce the Hopkins community to the work of newly appointed and promoted professors and to provide a forum. Jeff and I were just talking about it. It's a great forum to learn about what each other is doing. And so that's the other main purpose of this series. We're looking forward to a great series this year. Hopefully you've all seen the flyer that lists all the speakers that we have over the next few months. But today we're very honored to have Dr. Jeff Leek talk to us. Today, to say that Dr. Leek's research focuses on public health genomics, data science as a science, and research on the scientific literature really only begins to scratch the surface of all he has done and continues to do. I really think it's fair to say that he has helped transform how we think about data science and the role it plays in the future of the public's health. Yes, he has developed statistical methods, he's developed software and data resources that are among the most widely used statistical tools in genomics. But he's also conducted high-profile research on the reliability of the published medical literature and is helping to create a new field on the human behavioral component of data analysis. Now, what many of you might know Jeff best for is his role as co-creator of the Johns Hopkins Data Science Specialization on Coursera, or MOOC, that has enrolled over 6 million people, which is just truly remarkable. I think he probably comes closest to most of us in delivering on our mission of protecting health, saving lives, millions at a time. He's also a leader in research to the broader scientific community through his co-written blog, Simply Statistics. And in addition to publishing extensively in the peer-reviewed literature, Jeff has 2 books, including the bestseller, The Elements of Data Analytics Style. He's also created software packages and large-scale collection of processed RNA sequencing data. And in 2017, he was the recipient of the Johns Hopkins University Catalyst Award for the new blue-collar remote data science jobs for improving economic security and health. And I think we'll be hearing about some of that today. He has co-directed the Johns Hopkins Data Science Lab since 2013, and in 2015, he helped redesign the Biostatistics PhD core curriculum to include data science in a major way. He has advised 7 PhD students and has been recognized as an outstanding teacher by the school several times. He is editor-in-chief of Biostatistics, the journal Biostatistics, and has served as associate editor for the Journal of the American Statistical Association. He is widely credited with having instituted innovative approaches to speed up the review process and broaden the scope of the journal Biostatistics. Dr. Leek received his BS degree in mathematics from Utah State University and his MS and PhD degrees in biostatistics from the University of Washington. He then went on and completed a postdoctoral fellow program in stem cell biology at Mount Sinai's Black Family Stem Cell Institute, and also a postdoctoral fellowship in computational biology at the Johns Hopkins School of Medicine in the Department of Oncology. Following his postdoc training in 2009, Jeff was appointed assistant professor in our Department of Biostatistics, and he quickly rose to the rank of full professor in the department. I am really looking forward to Jeff's presentation, as I know many of you are. He's a remarkable individual, has so much, he has contributed so much to the field of biostatistics, but way beyond that particular field of biostatistics and data science. And I think we'll be learning about some of his contributions today. So, Dr. Leek, the floor is all yours.
Great. We were just talking about how I've given this talk a couple of times as warm-ups before I came here at seminars. And talking in front of your colleagues is always way more stressful than talking in front of other people. So thank you all for coming here today. And also, I thought I'd lead off here a little bit with the usually what's at the tail end of the talk. If you get to this point in a career, you didn't do it by yourself, for sure. And so I wanted to thank all of the people, students and postdocs, great mentors, my collaborators in genomics, my collaborators in data science, the data science staff, Hopkins administration, and then a bunch of partners you'll hear a lot more about, and especially my family, who have been incredibly supportive throughout all of this. And so in the immortal words of Kevin Durant, all of you are the real MVPs. And I really appreciate you being here today to hear me talk. So my research program is a little eclectic, and it sort of started off in statistical genomics. And that was actually fortuitous because the next generation sequencing machines sort of were invented right around the time that I graduated from my PhD. And so I started using those technologies. And that sort of was just in advance of, it sort of ran the data science explosion in many other fields. And so we had this unique advantage of a few years head start on thinking about data science and data wrangling that, industry started catching up to after the scientific enterprise. And then we had this really interesting opportunity to jump into online education with Coursera. And we were able to do that, I think, at least from my perspective, in large part because we already had these sort of ideas from statistical genomics. And if there's one thing that sort of has underlined my research program, if you read any applicant to a biostatistics PhD program, they almost all say in their letter somewhere, I know something about math and I want to do something to help people. Like that's the default assumption that a biostat PhD student comes in. And that's sort of, if there's something that's driven what I've done the whole time I'm here, is that same kind of principle of, I know a little bit about math and I'd like to use it to help people. So, and this has been an amazing place to do that. So this project I'm going to tell you about feels a lot like this. It's an area that, as a biostatistician, I didn't have a lot of experience in when I first started. It's community-based research, it's tech development. So it often feels like we're fixing the train track as we're sort of going down the train track. And so I think you'll probably get a little bit of a sense of that as I go on, of all the sort of mistakes and the sort of side directions that we took as we were going. But so far, the train hasn't fallen off the tracks. So I'm going to start by talking about the motivating problem that kind of started this whole project out, and the idea of income inequality as a public health problem. And so if you've read anything in the news recently, you've probably read about income inequality or income mobility. It's in the New York Times, it's in the Washington Post, it's on a lot of people's minds, especially in the era of automation. But it's not only a problem of economics, it's also a problem of public health. So this is data that was collected by the Raj Chetty group at Harvard, and it shows on the x-axis the income percentile for a person, so what percentage their income at. People who have less money are on the left-hand side, and people who have more money are on the right-hand side. Men are in purple, and men are in yellow, and women are in purple. And you can see that life expectancy has a pretty dramatic increase if you're compare the 20th percentile to, say, the 80th percentile. Now, that's not causation, but it is pretty tightly correlated with how much money you make. And it's a 7-year gap, which is a pretty significant change in life expectancy based on how much money you make. The real action, though, is in the sort of going from the 10th percentile to the 50th percentile, making that's a lot less of a gap in terms of absolute dollar amount, but it's got just as big an impact in terms of public health implications. And it's not just life expectancy. So this shows on the x-axis the income percentile of a person's parents, and on the y-axis, the fraction of their children that are incarcerated by the time that they're 30. And so you can see that the 20th percentile compared to the 80th percentile, there's a dramatic difference in the fraction of children that are incarcerated, depending on whether they have money or they don't have money, if their parents do. And again, a huge amount of the action is between the 10th percentile and the 50th percentile of income. So we've been thinking about that problem a little bit and the health implications of this economic problem for a little while. And one of the reasons why this is so deeply unfair is because at the same time that there's this public health implication of economic inequality, there's also less and less economic mobility in the United States. So this shows a map of for people whose parents are in the 20th percentile or below in income, what's the median income for those children when they reach age 34? And so red is very low income for those people, and as it gets more blue, you get more income. If you zoom in to a neighborhood we know very well, the black dot is the School of Public Health. This is the neighborhood around the School of Public Health. This is the median income for people of all, whether their parents were rich, poor, or otherwise. This is the median income for people born in this neighborhood at age 34. The family median income is $19,000 a year. That's a family income. And so that sort of mobility of moving from sort of low income to high income is a consequence of the fact that talent is evenly distributed, but opportunity is not evenly distributed. And so a question we asked ourselves, is it possible to address that problem? Just to show you that it's not just cities, I'm showing you here Pocatello, Idaho. So this is the town I grew up in. And just north of it, there's a large section of that community where if you grew up poor, you will likely end up poor as well. So it's a rural problem, it's an urban problem, it's a United States problem. And so you might be asking yourself, what does this have to do with education? Well, it turns out that education is still the single best intervention for addressing this problem that we've ever invented. And so I'm going to talk a little bit about this idea of a mobility rate. This is, again, invented by the Raj-Chetty group. It consists of a probability of having access to education times a probability of being successful once you do have conditioned on having access to that education. And so access is the fraction of students who go to a particular school who have parents that come from the bottom quintile or the lowest 20% of income. And success in this definition is students who end up in the 80th percentile of income or higher after going to that college. So you can make a plot. This is a plot of colleges. So every single dot on this plot is one of the colleges in the US. And you can see access on the x-axis. And on the y-axis is success rate. That should be T. What you see, for example, someplace like the university we are at, Johns Hopkins, it's a relatively hard university to get into if your parents don't have very much money. But if you get into that university, you have a very high chance of having high income when you complete. Moreover, this is remarkably consistent. So this is showing a plot of parents' income quantile on the x-axis versus the fraction of kids that come from that type of college that end up in the top 20%. And so each color represents a type of university. And so the thing that's really striking about this graph is, as I mentioned before, if your parents don't have very much money, you are very likely to not have very much money when you grow up. But that goes away if you go to one of these universities, because regardless of what your parents' income are, it's pretty flat across. You end up, universities have a consistent rate of success regardless of how much money you make, or your parents made. And so here, for example, is Johns Hopkins, which is right near the top with the elite Ivy League and et cetera universities. And so pretty much regardless of, even if your parents come from the lowest 20% of income, if you go to Hopkins, you'll have a really good chance of having a high income when you complete. So this mobility rate consists of two parts. The mobility rate consists of access and success. And as I showed you, Johns Hopkins has very low access but high success. These are the top 5 colleges in the entire United States in terms of mobility rate. So that's multiplying access by success. And you can see that they all sort of share something in common. They're usually public. They're usually very inexpensive. They usually have very high access rates. And they achieve their mobility rate by either having a really high access rate, where 40% of people can get in from the lowest income percentile, but a relatively low success rate, or the other way around. They have really high success rates, but low access rates. And what that means is these are the top ones in the country. 9.9 is the top of the line in terms of mobility rate. And so we're going to be talking about, this is the number that we were sort of interested in trying to address, this mobility rate. So you might now be asking yourself, what does this have to do with scalable data science education? Well, as I mentioned, the reason why we got interested in this problem is because we've been doing this online education for a little while now, and we've been teaching these massive online open courses, which have really had lots of people enroll in them. And we've been curious as to how does that relate, and can we use this sort of technology to address that mobility rate? And there's this advantage that we're kind of in this data moment. As I mentioned, genomics was a little ways ahead of the game, but a lot of people have caught up now, and there's sort of most tech companies, most nonprofits, most governments are sort of desperate for data scientists. And so we're wondering if we can match this industry demand with using tools to train people to try to create an engine for economic mobility. And so we have these programs. These numbers are now out of date, as you heard in the introduction. These are I think about a year old now, but these are different programs that we run online. And it's exciting that so many people enrolled, but there's some things that we wanted to know about these programs. And so one of my postdocs, Abuzar Hadavan, who's sitting here in the audience, did a really interesting economic analysis where he basically surveyed all of the people that enrolled in one of the MOOCs. That means even people that just were tourists and showed up for one day and then bailed right out. He sort of sent it to the cross section of that entire group and asked them all sorts of information about their economic outcomes, both before and after the program. And so you can look at the sample, the survey sample of people and the questions that we asked them. We have this alternative source of data, which is what the data that these same folks input into the Coursera platform. And you can see we're relatively comparable in terms of the demographics for the data that we have. And you can do propensity score matching and sort of estimate what's the sort of impact of taking the data science specialization. And so if you look here, the yellow distribution is for people who showed up but never did anything, never passed a class. The blue distribution is for people who completed up to half the program. And the green is for people that completed up to the entire program, from 5 to all the way to the 10 classes. And you can see that there's a relatively significant bump. Depending on how you analyze the data and the sensitivity to different choices about the matching, it can be anywhere from a few $1,000s to $10,000 bump for completing what's a $1,000 online Coursera program. So that's in the first year of income. So that was pretty exciting. And it's sort of comparable in terms of a cost-benefit analysis. It's sort of, I'm plotting the cost of a program on the x-axis and the increase in earnings on the y-axis. And you can see that the increase in earnings is sort of equivalent to what you would get for doing a college degree, but the cost is obviously a lot less for doing some kind of the program like this. One of the reasons why we have that advantage is because we're training people in a very specific, very in-demand technical skill. We're not sort of trying to teach to an entire university where there's a whole bunch of different degrees that might have different values. And so this is the plot of the data from Abuzar's work. And you can see here the income before Coursera Data Science on the x-axis, the income after Coursera Data Science on the y-axis. There's some confounding factors. Time has elapsed in between those two numbers. So some people just moved up and made more money. But in general, you see the dots are sort of above the line. The thing that isn't, maybe necessarily as interesting to us, if you think about the sort of median Coursera user of our courses, it's not necessarily someone who doesn't have very much money. You can see a lot of people had good salaries before they started the program. But these folks, you can kind of see highlighted in green, are people who had below poverty level income before taking the program and ended up at 80th percentile or higher of the income distribution after completing the program. And so that's a very small fraction of people that fit this category, but it's a very inspiring fraction of people. And that's sort of what we wanted to see if we could manufacture. And so, as I mentioned, if you take the modal user of a Coursera data science course, it's a white collar, upper middle class, white software engineer from Silicon Valley. That's like the typical, prototypical user of a Coursera class. And you can see that in the distribution of the education of people who took our survey. Most of the people have at least a college degree already. And so while that's great, and we love educating those people, and we want to help educate those people too, everybody deserves to learn some data science. We also want to see if we can sort of address the broader societal question that we had in mind at the beginning. So I'm a statistician by training, and so I feel like I had to have at least one equation in my dean's lecture, and so this will be it. So if you were hoping for more, sorry. But our goal here is to basically maximize the mobility rate, and it's a penalized maximization because we're at a university, we don't have infinite money, and we don't have infinite time. So how do we do this while sort of dealing with those penalties that we have to deal with? And so I'm going to first talk about maximizing the mobility rate. So imagine, and this is sort of an exercise that Abuzar and Shannon Ellis, who's a former postdoc as well, myself and Sean Cross did in my office about a year and a half ago. Imagine you're a person that has very low income and you live in the neighborhood around Hopkins and you want to take that person and turn them into a data scientist, what are the things that might get in your way? And so these are the things that might get in your way. So first of all, you'd have to know that there's a thing called data science and that you could have a job in it. You would maybe need some money so that you would have a place to be and a place to live. You'd need an expensive computer. You'd need appropriate programs, access to instructors, right jobs being posted, access to connections. You'd need a lot of stuff. And so the rest of the talk is pretty much dedicated to the project we've done for the last year and a half or so, where our goal has been to just knock these down one at a time. And so the first one we started to talk about was expensive computer. So it's been said that a data scientist is a statistician who works on a MacBook Pro. And if you walked around our department, you would see that that's pretty much true. And so the first thing we wanted to do is see if we could fix that problem. And so what we did was we started focusing on, could you do the whole program on a Chromebook? Could you do the whole program on a computer that is only an internet browser? That's the only thing it can do. And so we wanted to build a program that was entirely doable through the web, any computer with an internet connection and a web browser. So that was a sort of a guiding principle of all the content we were going to develop. This is a top-of-the-line Chromebook. It costs $450. You can get them for as cheap as like $100, and you can check them out from most public libraries now. So I tried doing data science on a Chromebook a couple of years ago, and Brian Caffo and I both tried this experiment, and it was super challenging for it used to be, and is increasingly over time as technology and cloud computing has gotten better. It's easier and easier to be a data scientist on a Chromebook. So you can make presentations using Google Slides, as you're seeing here before you. You can do sort of spreadsheets in Google Sheets. But the big one, and this is the thing that really made the technology piece that made all of this really possible. Over the last few years, we've partnered a lot with the company RStudio, who develops the RStudio interface. If you've ever done anything with RStudio, they're a company as well, and they were developing this new thing called RStudio Cloud, which is basically you navigate to the website rstudio.cloud, you log in with Google, and you have like an RStudio browser right there that you can work on through the web. And so that made it possible for us to teach this entire program without people ever having to install anything on their computer. So that was sort of the first part, was addressing the computer. The next thing is that, one of the reasons why most of the people that use our programs are Silicon Valley software engineers is because they hear about it on Twitter or LinkedIn or social networks. And if you don't have access to the data science Twitter sphere, which is like, a pretty narrow group of people you would have to be associated with, you might not have even known that this was a big opportunity. And so what we did was we sort of looked at this data and we said, most of the people coming into our MOOCs have a college degree or more. That's not just our MOOCs, by the way. Every piece of research on MOOCs, whether it's us, edX, anybody else, they're all saying the same thing, which is that MOOCs basically so far have been serving people who are already served by other types of education. That's something that is a pretty established fact at this point. So what we wanted to do was actually find a partner who could help us identify potential people who could go through our program and also support us, because we've never delivered this kind of education in the community before. And so Liz and Ed, who are sitting in the back there, partnered with us from Yo and Hebcac, and they've taught us so much. They're incredible partners, and they helped us identify people to go through the program. They helped us support those people as they were going through those programs, and they've been teaching us about how to deliver these sort of community-based education interventions. So that's been an amazing partnership, and it allowed us to reach a population of people who maybe would not have known about data science historically. So then the next thing is, okay, so great, now we have knowing about data science, we've gotten rid of the expensive computer part, we need to have an appropriate program. Now, even our Coursera program that we run online costs about $1,000, and you kind of have to know programming before you start to really be able to do the program well, which is another reason why it's mostly software engineers in there. But there's this interesting problem, which is that most of data science doesn't require a PhD. Most of data science, real data science, the data science that companies are worried about and that we're worried about around here, is extracting commas out of files and matching IDs to get those data sets to link up and doing things like that, which you can definitely train people to do in less time than it takes to do a PhD. And so a question was, could we develop a program like that? And another interesting sort of concept that we were sort of some of the first people to recognize, but lots of people are noticing now, is that R has turned into something where you can do magic. So this on the left is code that's markdown code, or R markdown code specifically, and that R markdown code generates this website. So I write 10 lines of R Markdown code, and I can have a website on GitHub and host it for free. If you were a web developer, the amount of web development you would have to do to create this website before this kind of thing existed, that would be, a year of web development. Now it's like 5 or 6 lines of code. Similarly, there are things like this. This is a Flex dashboard. I know it's very small here, but I wanted to show you all of the code that creates this interactive web app where you can put in your BMI measurements, and it will show you your BMI on the app, and you can mess around with it and create this interactive graphic. It's 36 lines of R code. So again, this is for people who have ever built something like that before this technology existed. This looks like wizardry. I mean, it's really Harry Potter level stuff. And so that's not just those technologies that are flashy. This is code. Well, it's abstracted code that lets you connect to a BigQuery database and run computations on 3 million lines of data on a Google BigQuery database right from R using commands like dplyr commands that we would teach in our first year R programming class. And so these technologies, which allow you to also do things like pull data out of APIs, access databases, this is all stuff that has just come out in the last 4 or 5 years. And so this program is predicated on the fact that once you recognize that, you realize you can teach people to do what's essentially wizardry in very much less time because you don't have to teach them as much code and as many concepts. And so now the big challenge for us is that we had this idea. We thought we could use data science education. We wanted to build a program, but there's this big penalty of, it's basically a few of us in our spare time in a side project trying to build a program, and that's a little stressful. And the other thing that's interesting about this is, I don't know if you just saw this. This came out this week. John Oliver's Screed this week was on automation, and he talked at the end of that about an idea that I think is something that a lot of people are thinking about, which is that this is an amazing book that I'm just reading now about the episodic career. It's that for most people, they're not going to have one career over the next, because there's this revolution happening with automation and the AI and all of that. People aren't going to have one career. They might have 5 or 6 different careers over time. And so as educators, we're going to have to be able to distribute education that matches the pace of people changing careers every few years. And so we've been thinking a lot in the data science lab about how do we build technologies that allow us to match that kind of breakneck speed of building those educational programs. And so what are the goals of this program? It has to be maintainable, updatable, creatable in a distributed way, accessible, and free or low cost. So I'm going to talk about maintainable first. So this is how we, I don't know if Jessica's here in the audience, but Jessica is an amazing videographer who we've hired, and she has helped us build all of our online programs. And this is how we record videos, which is time consuming. And if an R package breaks and you have to redo all the videos for a class, this is an extremely hard thing to do, is to get 30 or 40 more hours of video time recorded. And also people hate my voice. If there's one thing we learned from the Coursera class, it's that my voice is the worst and everybody hates it. So I think the only thing that gets complained about more than my voice is Brian Caffo's statistical inference class. So it's me and him neck and neck for worst part of the program. And so one thing we wanted to be able to do is be able to make new videos quickly. Another is that it has to be updatable. So in our original program, we have this course called Getting and Cleaning Data. It has 34,000, at the time I took this screenshot, there were 34,000 final projects from that class available from GitHub. So you can look at those 34,000 projects, and Sarah Wang, who's I think maybe also here, she did this analysis in my advanced data science class. On the x-axis is time, and on the y-axis is the frequency of calling a particular R library. So you can see one stands out, right? So there's one package that immediately sweeps to dominance, which is dplyr. This package, so this Getting and Cleaning Data class, we thought we were being very clever. It was very new. Hadley Wickham released the dplyr package the day the class was released and rendered the whole class obsolete. So it's very frustrating, and it really taught us the lesson that we have to be able to rapidly change the material in case Hadley Wickham decides to hose us again. And so obviously I'm kidding about that. The fact that these packages exist is one of the things that allows us to do this program, but it does teach us a lesson as educators. They have to be creatable in a distributed way. These are all people that contributed content to this program that we've developed, and we have to coordinate across all of these different people generating and contributing content. We have to be able to do that and work together to do it. it has to be accessible. And I mean that in the sense of ADA, Americans with Disability Act accessible. And the reason why is Berkeley was required to take down all of their MOOCs because they weren't ADA compliant. So they lost a lawsuit and had to take down all of their MOOCs. So this is something was on our minds that we didn't want to be in that have that problem ourselves. And then the program must be free or low cost. And that's because sort of what's really happening with a lot of MOOCs at a lot of places, this is a recent science paper that was talking about this idea, but a lot of places are really driving MOOCs towards revenue generating executive programs that make a lot of money for universities, which is great, but that's not great if the goal is to try to help people that don't have any money. So we started thinking about that. And so what we did was we already were publishing these books on this platform called LeanPub. And so one of the cool things about this LeanPub platform, you can see that slider bar there. We can suggest a price that people should pay, and then they can also slide that slider bar down to 0 and pay 0. So it's more like a donation for taking the class. So we really liked that idea, that model. And they already kind of did some things that we liked and we knew them pretty well. So we partnered with them and they basically built us a bespoke MOOC platform so that we could run MOOCs on this LeanPub platform as well. And so this platform has a couple of cool features. One is we write the courses in what's called Markdown. That's that same language we use with our Markdown. So it's already kind of natural and easy to write. And so that text on the left produces that MOOC on the right. So you can write the text files and then have the MOOC platform generate the MOOCs. This means that we can very easily edit them and update them because we're just editing text files. Quizzes are similarly, this is a quiz that we've marked up. So this is a quiz where we can tell which answers are the correct answers, which answers are the optional wrong answers. You can have it randomize how many answers it shows. All of this is just text-based markup language. So we can do things like automatically generate new quiz questions using our code to generate new quizzes to prevent things like cheating. Then the next thing that everybody thinks about when they think about MOOCs is, videos. I was already feeling a little self-conscious about my voice because of all the complaints. So I started to think about how I could eliminate that part of the MOOCs for me. And a former sort of research scientist that worked for us, who's now a PhD student at UC San Diego, Sean Cross, had this idea that we could use Amazon Polly, which is the text-to-voice synthesis software produced by Amazon. So if you have an Echo in your house, that voice that you hear from the Echo is being generated by a piece of software. That same software you can use to generate videos. And so Sean built this software that allowed us to take a series of images and then a text file that has one paragraph per image, and it will combine them together and generate an MP4, which you can then create and put on YouTube. So the idea is now if a video goes out of date, it's no longer, can I get this person to come into the office and can we set up the green screen and all that kind of stuff? We just edit a text file, click recompile, and we've kind of automated ourselves away with AI. So that's the ARI package. And then John Muscelli, who's sitting right here front and center, with Shannon Ellis, but largely John's work, developed this Didactor package. And what that basically lets us do is, if you have a set of Google Slides and you have a GitHub repository with all these text files you need, you can run this R code and it will create the videos, upload them to YouTube, send everything to LeanPub, compile everything, and you can update your entire MOOC with a few lines of R code. And so that allows us to regenerate. If we want to regenerate our entire MOOC program, which is 12 courses long, we can regenerate the whole thing in an hour or two of just running R commands. So that's dramatically sped up both the way that we generate the content, but also the way that we maintain it. So these are all technologies that I think it's one of the cool things, it's not properly biostatistics in the sense that we're not doing modeling of data or equations, but it is the fact that there's this whole ecosystem of data things that you can do now that you couldn't do before because of R and because of these new technologies. And we have clever people here who can take advantage of them. That's been really exciting to work with. And then the last thing that we did was, one of the things you want to do if you're learning R or any programming language is you want to practice. And the best way to practice would be we'd create lots of problems for people one at a time, have them do them and grade them. But that's really hard to do. Again, it's not something that scales. So a couple of years ago, a master's student in Brian Caffo built this thing called Swirl. And then Sean took it over after that. And the idea is you can write, again, a very simple kind of markup text file, and it will create an interactive tutorial that people can do in R. So it talks to you, it gives you a feedback, you can put the commands in, it says, nice try, you should have done something else. So we could generate interactive sort of tutorials for people as well. So what we decided to do was, okay, so we have this principle of we want to get somebody who has never heard of data science before all the way into a data science job. What are the components of doing that? So we had this idea. This is, again, largely the work of Abuzar and Shannon, who came up with all these ideas of how to kind of put this program together. And then John and Leah and Leo and Sarah and lots of other people, two separate Sarahs, who contributed to building the content. So the first part of the program is sort of introducing people to like what is data science, teaching them how to use a computer, how to use Google and things like that. It turns out for the people that we've put through the program so far, this is a breeze for people. They're really easy to do it. So right now it's mostly confidence building as opposed to really teaching people stuff. Then we have these courses on organizing projects and version control. The cool thing about this is once you kind of get to that point of version control, they've learned R Markdown, they've learned GitHub, and they can put up their own website. So just a few weeks into the program, they have their own website up. It's very sort of inspiring and cool as a first thing that you can do. Then there's a set of courses that are basically how to do really basic data analysis and data science, which is the sort of the core market that we're trying to address with the folks that are coming out of this. And then the thing that we didn't put too much in our original program, but we really thought was important here was soft skills. So we're talking about training people to go and take jobs. And we wanted to think, if they don't already have jobs, they probably need to learn how to like give us data science presentation or do a data science interview or have a LinkedIn profile. So the classes are about that. Those last set of classes are about that. So the timeline for what we did was, so this is all started in February 2018, the idea of creating this content. We had our first meeting with the Yo and Hebcack folks in April, at which point we were like, great, let's do this thing. Let's do a pilot. Then they were like, let's do a pilot, but let's start in May. And we were like, so you look at the timeline, February to May, and you go back and you look at this amount of course material you have to generate. And so there was a little bit of a moment like this where we were trying to figure out how quickly we could generate content. But fortunately, we had built all these tools thanks to all the amazing technologists we've worked with here and LeanPub and our studio and all of that. And so this sort of scrappy group of people put together all of that content on that timeline, more or less. And we had this is sort of a screenshot of the Trello board of who was assigned. Abuzar and Shannon did a huge amount of work, but lots of people made contributions. And we had a kind of a coordinated effort where we could use these technologies to build all of this on GitHub so we could build it really quickly. And then we could use our studio to have projects and we could manage students in those projects because we didn't know how many people were going to show up. We've had, millions of people show up to our classes before, so we wanted to make sure we were prepared for that. And our studio kind of helped us set up a system where we could easily manage thousands of people at a time if we needed to, as they were doing these sorts of projects. And so one of the cool things about all of the programs we've generated here is people get a portfolio by the time they finish. We always have these projects that they do during the course of the courses that we teach them, and they put those projects up on GitHub, and that acts as sort of a virtual resume of what their skills are when they go out looking for jobs. So this has projects like, for example, they were given a 538 graphic, and they had to reproduce that 538 graphic as closely as possible using ggplot, things like that, so that they could sort of develop skills that would be useful when they went out and show them off. So that was sort of the program component of it. So we built the MOOC program, that sort of stuff we had already done. And now we get into the part where we were really, really not experts and we had to learn a lot. And so the idea is we still have to get, even though the computer's only $450, that's still a lot of money. We want people, if you've ever tried to learn R programming, you know that it's super duper frustrating. And if you don't have anybody to talk to, you almost certainly will quit. So we wanted to have people to have access to instruction, and then we wanted them to have some kind of income security. We were talking about working with people who don't have talent, but don't necessarily have income security, and we want them to be able to focus on doing this program. So we layered on top of this, and this is now a program that Ashley Johnson's running. She's sitting right back there, the CBDS Plus program. And the idea is we give people free laptops, free Chromebooks. We give them access to an online Slack channel. We give them job search assistance. And then we pay them to complete the courses so that they can afford to spend the time working on the courses. And then they get 3 hours a week of in-person office hours. in the title of the talk, there was that scalable solution. And this is the least scalable part. Putting people in a room is the least scalable part of this whole thing. And so there's a big trade-off that you have to think about, which is the more hours you put somebody in a room, the better the learning experience for the people taking the class. But it's also the more expensive and the less scalable the program is. So a lot of our future work is figuring out where that balance is. How do we drive the number of hours down and maintain quality while also maintaining scalability? So this is sort of the two programs that we built. Again, this was all built sort of on the fly over the last year in collaboration with lots of people. And then we went back to HEPCAC and we started a pilot. So they identified these two students for us to take through as the first two through the program. And they had to take a huge bet on us because we looked ragtag when we showed up. We had a quarter of a program. We had never worked in this community before. I mean, we could not have looked less ragtag. It wouldn't have been possible. More ragtag, it wouldn't have been possible. But fortunately, these two were sort of amazing, and they went through the program, and we did this pilot with them. And so the May 21st, the learning begins, and we made up this sort of schedule. But we had no idea, we had no idea how long it would take people to finish this. We had no earthly idea. So we just totally made up a number out of our, we had these conversations in my office. It was like, a month? Nah, that's too short. 6 months? That's too long. So we sort of settled on 3 months, but with absolutely no data to back that decision up, as any data scientist would. And that's sort of characteristic of everything we've done here is before we do it, we don't collect any data, we just do something. And so it turns out it ended up taking a little bit longer. That was mostly because we, at a certain point, I think it was around the third or fourth checkpoint, the students caught up to us and got ahead of us. And then we were trying to make content just fast enough to get out ahead of them so that they could do the new content. But they ended up finishing, which is great. That was really exciting because it sort of proved the hypothesis that, the hypothesis that we always had, which is that talent is evenly distributed, even if opportunity isn't. This sort of was a compelling piece of preliminary data that we were right about that. But then we ran into another problem. So now now they're done. They've been taught. They can do data science. Now what? And so we thought about trying to get them jobs and put them directly into jobs. And this is a tweet, but it's a fair representation of data science job advertisements. So this is the actual responsibilities of a data scientist at a company, but the job ad lists the qualifications as this. So you can see that there's a little bit of a mismatch between what the company actually wants to get done and what they're advertising for in terms of skills. And so not to pick on a particular company, but I just picked a job ad at random on Monster. And this is a job like that one I just showed you. It's a job that easily the people that we trained could do, but they require a bachelor's with 5 years of experience to even get in the door. And so at first, our hypothesis was, this is just HR departments being silly and they don't know what they're doing, and we're going to fix this problem, no problem. But it turns out they have talked to lawyers and we hadn't. So there's this thing called the Fair Labors and Standard Act, which I had not heard of until this part of the project. You remember the guy putting the things in front of the train track as he went? This is me putting the pieces together. So the Fair Labor and Standard Act classifies employees into two types, which I didn't know about until about 3 months ago. There's exempt and non-exempt. Exempt means you're exempt from paying minimum wage and you're exempt from paying overtime. So technically, if you're a professor in the university, they can pay you $2 an hour and ask you to work 100 hours a week. They assume you won't do that because you've got this PhD and stuff like that, and you wouldn't take that job. But there are 6 categories of things that allow you to be exempt, an exempt employee. The people we train happen to skirt right between the professional exemption and the computer professional exemption, right in between those two. And so they don't quite qualify for any of the exemptions under the Fair Labor and Standards Act. This is a big problem because what we want to be able to do is open up all these data science jobs to them. But the reason why they have bachelor's degree listed is because that if you have a bachelor's degree, you can get the professional exemption and you can be an exempt position. So this was something we thought, okay, this is going to be a problem. It's now us versus the HR algorithms, and we have to go and convince people to reclassify jobs from exempt jobs to non-exempt jobs, and that's going to take a while. And so fortunately, again, by sort of luck, Jamie McGovern, who's the husband of my wife's best friend, is like a top level elite consultant and had just happened to have some spare time on his hands, and I twisted his arm a little bit. And then he was like really into this idea. And so we're this close to getting people to the finish line that we wanted to. And so Jamie came along and helped me found this company, Problem Forward Data Science. And so this is all credit goes to Jamie, who's sitting in the audience as well, because I have not the first idea about how to run a company, but he does, fortunately. So we've kind of started this company, and we can contract with the same companies that can't directly hire the people we're training because they won't classify them in the right way. They can contract with us, we can classify them in the right way and have them do the work, the same work they would have done for those companies, which allows us to a good opportunity to expand, but it also gives us some time to start talking with companies about how to reclassify people and stuff like that. So we've been able to hire people through this company. And the other cool thing that Jamie and I worked on and were able to do, thanks to the tech transfer people here at Hopkins, is that's where the company is headquartered. So if you remember the plot from the beginning where economic mobility is low, we're able to put a data science tech company like right smack dab in the middle of that so people can walk to work or take the subway to work. And so that's allowing us to build opportunities in places that they weren't. So that's sort of trying to complete that pipeline of getting people all the way to the finish line and being able to have the kind of income that their talents allow them to have. And so this is sort of the place that we find ourselves at right now. We've been thinking about these problems a lot, about how to address these different barriers. And now we kind of have, bit by bit built out the different parts of this that allow us to do it. And so we just found out today, actually, that the Able Foundation is going to fund 10 more people through the program. So we're super psyched about that. And we have, from this Catalyst grant that I got, funding for another 20 people. So we have 30 people that we're going to hopefully be able to move through this pipeline. And I'm sure we'll be learning along the way all the other things we haven't figured out yet. So where do we stand now? This is that chart of mobility rate, right, by college. And so you can see that the top rate is 9.9%. So that's what we're trying to beat. And so one thing that we can do is we can jack the access rate up to 100%. So that's already, we've got a big win there because we could just set that number at 100. So all we got to do is be better than 9.9% successful, and that we are sure we can do because we've got these talented people coming through. And I hesitate to say what that number is going to be. We've just done these pilots, but if we can keep it up, 50, 60, 70% of success rate, this will be one of the sort of most biggest engines of economic mobility that exists in the US. So we're really excited about that. My research started in statistical genomics, and many of the people here in the audience supporting me today are people I've worked with in statistical genomics for years, and I didn't get to talk about their work, but they have also done awesome stuff, and if I could give 3 Dean's lectures, I would give other ones. Maybe we'll see if I get invited back. I'm kidding. But now we're sort of thinking about what's the next stage. So we've kind of built this program, but the other cool thing about this program is just like the sequencing machine I talked about at the very beginning of my sort of talk was like a new technology that allowed us to collect a type of data that we could never collect before. These online platforms allow us to collect a type of data in education that we never were able to collect before. So if you think about what data you collect in your in-person class, it's the assignment they turned in, the final exam, and maybe their like review of you at the end of the term. Like that's the sum total of the data you collect. But these platforms collect data on every action the person takes, all the things they're doing with our programming, everything that they're doing along the way. And so we can start to model that. And so this is the sort of data science process adapted again from that famous data scientist, Hadley Wickham. And this is the parts of the data science process of analyzing a data set. And if you label it with the tools I like to use, this is the labels of the tools that I like to use. But then if you label it with the reasons why I use those tools, this is the reasons why I use those tools. And so I think if every data scientist in here made this similar plot, they would have a similarly low justifications for why they picked all the things that they did. And so what we're doing now is we're developing our packages. This is again built by Sean Cross, who's now at UCSD. This is a package that's like spyware for R that lets us study what people do when they're analyzing data. So they turn it on and then they start analyzing data, and then we collect data on all the commands they put in. So we gave, for example, we can randomize people to do an analysis, and for half of them, we nudge them to not p-hack, not to try to find the smallest p-value. And for the other half, we don't nudge them to see if we can discourage p-hacking. Turns out that does not work. Super null. This is like one of the first experiments I ever ran as the scientist and not the statistician. Nothing. We found nothing. But the cool thing about this is this is the entire analysis one person did, they submitted. This is the analysis that somebody else did. It's much longer. And we now are developing sort of natural language processing tools with Lucy McGowan is doing natural language processing tools for like analyzing this data and labeling it with the different activities. And so, for example, you can find things like if you're an inexperienced analyst, you do more exploratory analysis. Once you get to be a medium experienced analyst, you do less exploratory analysis. And then once you're senior, you go back to doing tons of exploratory analysis. So there's these curves over time that we can detect and learn about how people do data analysis. And so, but again, all of this work, everything we're doing with Problem Forward, with HEBCAC, with the Data Science Lab is all really focused on this big picture question of, can we give people who have talent but not opportunity that opportunity, and can we use that to help encourage them? And then hopefully, like I said, it's correlation, not causation, but if we move people up the income ladder, hopefully we'll get a lot of public health benefits from that as well. So we're planning long-term studies around that. And so again, thanks. This is like, I mentioned a lot of these people as I was going, but it was I feel like mostly what I did with this project was like connective tissue between other people who are doing awesome things. And I assume it's going to be like this going forward, but looking forward to it. It's been an awesome way to work so far. And thank you for coming today. And thanks to Hopkins for being such a great place to do cool, weird stuff like this. Thank you.
Thanks so much, Jeff. That was absolutely phenomenal. It was great. Can you? I might have missed it, but can you talk a little bit about the experience of the two folks who went through the pilot program? How did they?
Yeah, I think that was an interesting experience because about a year ago, right around the time when we were starting this program, a person named Joe Chang, who is the developer of one of those packages, Shiny, came and gave a talk here. And we were planning on trying to roll this out in like a big way right at the start with like 100 people. And he said, "You're an idiot. Do not do that. Do it with like 2 people and see if you can make it work." And that was the best advice I ever got. And so we spent a lot of time, those two, we spent a huge amount of time interacting with them, getting their feedback. They really helpfully, like there were tons of bugs. We were making that content as we went. So there were definitely times where it was an error in our program that was causing them to get an error. And they gave us feedback on that. And so the other thing that was really eye-opening to us is, there's a lot of challenges that frankly, as a person who hasn't had to deal with those sorts of financial and housing insecurity challenges before, we had to learn a lot about how to work with folks like that. And that's been largely thanks to them and largely thanks to HEBCAC and Yo, who've been teaching us how to do that. As a biostatistician, we never had to do stuff like that before. And so we were definitely amateurs. I think we were naively amateurs at it at first, but we've been learning a lot. So they were great. They're awesome. Yeah. I'm like huge fans of both of them. So
almost co-developers, right?
Yeah. A little credit there. Yeah.
Questions? Yeah, Scott.
So I have 3 questions, actually.
How many of them are a comment and not a question?
Actually, only 2 of them are for you, and one's for them.
Okay.
So first, congratulations. That was totally brilliant. I'm totally inspired.
Thanks.
And, there's an eye hospital in India called Aravind Eye Hospital, and they take out cataracts for people who don't have very much money for basically nothing, I think. And then they charge everybody else who does have money enough to cover the costs of the eye surgery. Yeah. So, and they do hundreds of thousands of cataracts per year, maybe. So now, how much does it cost for each of these young people who don't have any money here to actually get them through in steady state? How much will it cost?
Yeah, that's a good question. So the real costs are, the bulk of the costs are the cost to give them the stipend, which we currently is $2,500, and then $500 for a laptop, so that's $3,000. And then the bulk of the cost is having people in the room to tutor people. And so the fewer hours, there's the trade-off that I was talking about. If it's 3 hours a week, then we can do a lot of people for very few program managers. And then the cost is $4,000. But like, let's say on the worst case scenario, like $6,000 a person. If they
So
go
if,
from
if it were 5,000, I could tell you, I would pay 10,000 in a millisecond to get to go through that program.
to go through the program.
Me, yeah, I need to know how to do those things.
Sold.
So now my question is, how many people would spend $10,000 to get to go through and to know that there was another person who went through who could help you get through, probably?
Cut those checks. This is my salesman.
Just raise your hand
This
if
is
you
my,
wanna.
it's my salesman.
Okay, well, I see a few options, and I just think you're onto something amazing, and congratulations.
Thank you. Oh, thanks. That's great. Yeah. Thank you, Scott. Yeah. Yeah, that's something where you've hit on a question we're thinking about, which is how we're going to sustain the funding model for it. And certainly one of the reasons why we thought this was cool is you can drive, all good public health interventions are cheap, right? So we're trying to make it as cheap as possible to do this kind of thing. Yeah.
It's one less thing. Think of the value of being, an older white person who's got a lot of money to get a chance to work with a younger East Baltimore resident who doesn't have that thing. Think how much you would learn from that person, and think how much better you'd feel about coming to work every day.
Yeah. Yeah.
We've got a question over here.
Hi, thank you. That was,
Yeah.
I agree, totally inspiring.
Oh, thanks.
I'm a biochemist, but trying to teach myself R. I love Swirl. I didn't know it was from here.
Oh, great. Awesome. Swirl fans, always Swirl
Yeah,
fans.
Swirl's the
Ryan,
best.
the inventor right there in the front.
Oh, I have to come shake your hand. Okay. But actually, along the lines of the previous statement, so as a student, if I don't have $10,000 and I can't help fund someone get through this, is there other ways that we could get involved, even if maybe we only have a limited computer science background, limited math, but really want to help? Like, what can we do?
Yeah, absolutely. So one of the things that we need very badly, and Ashley and I were just talking about today, is trying to set up a program where we could have people volunteer to help teach R. Certainly the people that have already gone through can help out, but also we'd love to have students and anybody who's interested come and help. So if you're talking about the cost, if we have volunteer help, it means it's not 10,000, it's much lower for the, Scott Ziegers of the world to be able to spend to help us do it. So yeah, so that any kind of volunteer help in terms of R and tutoring and things like that can really have a big impact for us in terms of being able to deliver the program to more people. Absolutely. Yeah, that's a great question. You should come up and find me afterwards.
Karen?
Jeff, that was wonderful, just like every talk of yours I've ever
Oh,
attended.
thanks, Karen.
I'm moved to follow up on this wonderful question back here. I have been sitting here thinking that I've been getting these source emails in the last few days about service learning.
Yeah.
And this seems like a fantastic new model of service learning. So people can volunteer, people can apprentice with you. But have you thought about whether there are other learning modalities, courses or projects or something by which, there could be something more formal with credit or something like that?
You mean for people to do credit at Hopkins to participate in the program?
That's
and things like
right.
that? Yeah. Certainly everything ranging from helping us so these courses, while they are better, and thanks to the first two people that went through the program, they're a lot better, but they're still, there's plenty to do and to fix and to add and things like that. So content creation, but also helping to deliver the program. There's a whole host of associated. One of the things we learned a lot from Ed and Liz and the folks down at Yo is that, the thing that was really inspiring is that the folks that went through the program, their data science skills were like really awesome. It was amazing how quickly they picked that part up. And so, but there's lots of associated things that we could imagine offering and helping people so that they can focus on this and they can really do good at it. And so, ideally, those volunteer services could span a series of, or course participation could be a series of things, not just teaching R too. So, but yeah, that would be awesome. That would be great.
Model proposed by NVIDIA.
Right.
I was in a meeting with NVIDIA yesterday. They're launching a trial of a program called Education Ambassador, where NVIDIA give the university all the slides, all the material, and free computational power to all the students. In return, the university will provide that class at a reduced cost.
Right.
And NVIDIA will train the professors on these new materials and will give each student a cloud space and computation to finish the course.
Right.
And they invite them to programs and stuff. But the university has to sign an agreement that this course will be offered to students at reduced costs.
Yeah, so that's something we could do. I think one of the things we've kind of That's great. Obviously, that's an awesome program, and I would be a big fan of doing things like that here. I think one thing we've been really careful to do in these programs so far, it has been to use technologies we already know how to use and would use, and sort of not to say that we wouldn't use NVIDIA because it's a big manufacturer and lots of people use it, but I don't use it right now. So I would be hesitant to teach those courses just because I don't know how to, being taught by the reps feels a little weird to be in a position like that. But definitely partnering with companies is something we do heavily. So we would love to talk to people about what's the best way to do that. I think the other side of this is something Jamie and I talk about a lot, which is, we're manufacturing the talent now. We also have to manufacture the demand. And so Jamie and I are spending a lot of our time thinking about how do you capture the demand that's sort of dispersed and make sure it's available to people who are in a community like that isn't, Baltimore's great about many things. It is not the data science tech hub of the world. And so Jamie and I are going to fix that. But, the idea is we need to sort of manufacture jobs that can be done by people where they live. You can't ask somebody to finish this program and immediately pick up and move to New York City, right? So how do you do that is something we've been spending a lot of time thinking about too.
So Jeff, this was phenomenal, but I do have a question, and this leads into what you were just saying. So what are those two graduates doing right now? And did you place them through your company?
They were both placed at Problem Forward, and so that's where they are right now.
That's where they are.
Yeah. And so and they're doing great. And the thing that's interesting is they show up at Problem Forward. They got employed at Problem Forward, and they were able to do the sort of data science work for companies, right? So they were doing now the actual work you have to do, and so that. All of this is, we have a small sample size, right? So it's not like I'm saying this is for sure going to work and it's always going to work, but I'm really inspired by the folks that went through it because it suggests that the hypothesis was right, that we could teach folks how to do this and that they could then execute that in a professional context. And so that's exciting. Yeah.
Just curious, what are the minimal educational requirements to start and execute the
Yeah, so the question was, what's the minimum? I'll repeat it. The question was, what's the minimum education requirements? And so we've kind of gone back and forth on this, and we're trying to, so there's a trade-off, right? The higher you put the requirements, the sort of less the delta is in the mobility rate. So you have this trade-off of where you want to go. At the moment, we're sort of we've sort of trying to identify people that have sort of a 10th grade reading and math level, and main thing being that they're like kind of going to stick to it and that they're determined to kind of go through the thing. And so that's, for the most part now, is Liz at Yo has been doing like all of that and doing a great job of that. And so we want to explore the space of that trade-off of, how far can we go down and dropping the prerequisites versus how much, what does that do to completion rates and successful placement rates and things like that. That's a longer term conversation though.
So when does the next cohort start?
They're already going. So the next 4 finish in April. So, and then there's going to be 4 that start pretty closely there after that. And so we have these, like I said, we have about 30 that we've got funded at the moment. But the goal is to start expanding the program. And part of that, again, is generating the sort of funding and the work on the training side, and also generating the demand on the employment side. And we're doing it all at the same time. So we'll figure it out. Again,
I'm sure
very much like this. So yeah.
Great.
All right.
Any last minute questions? No? Well, thank you very much.
Thank you very much. Thanks, everybody.